Here is our video walkthrough of the Advanced Encryption Standard. First, we'll be starting off with the electronic codebook encryption that takes 3 arguments, as well as the -E argument. The -E argument defines the block cipher mode. -I is used to define the input. -O is used to define the output. And -K is used to define the key. The key can be a combination of a string or 32-bit hex values.
Here you can see the text of the original B-movie script we provided. And now we can show the encrypted text that we received back from our algorithm. So that's fully encrypted using the electronic codebook block cipher mode.
Now we will show electronic codebook decrypt mode. Decrypt mode is similarly defined using one additional argument, -D. That one additional argument defines decrypt mode. We also take, once again, -I for input, -O for output, -K for key,
And now you can see our decrypted text. Now we will proceed to the code block chaining block cipher mode.
The block cipher mode uses 4 arguments. The 4 arguments include -I for input, -O for output, -C for cipher block chaining mode, -K for key, similarly defined like in the previous function, and -V for initialization vector. The initialization vector can be inputted in either a 16-bit or a 16-character input or a 32-character hex input.
Now you can see the cipher text from the code block chaining block cipher mode. Then we'll proceed to decrypt.
Once again, the decrypt function is similarly defined using a -D argument as well as a -C for cipher block chaining, -I for input, -O for output, -K and V as well. Now you can see the output has been successfully decrypted. Finally, we will show Galois counter mode. Galois counter mode takes the same arguments as previous, as well as one additional argument for tag, which is used only in the decrypt step. In this case, the initialization vector is optional, and if not provided, it will be returned to you.
There you can see the authentication tag was provided back to you. And that is the encrypted text using Galois counter mode.
Now, we will decrypt the text using -D to define decrypt mode, -G for Galois counter mode, -I for input, -O for output. Additionally, the input initialization vector is required in this case, even if you did not input it, as well as the tag that was outputted to you, which will be used in the authentication step, as well as the key. As you can see, both the input authentication tag is returned to you and the recalculated decryption authentication tag. And if both those tags are the same, tag authenticated will be returned as well.
And there you can see we have the properly decrypted text.
Now, we will show the interoperability of our program. This is done through an additional software that we found by searching AES calculator in Google. There are plenty of outputs of all different software. As you can see here, we're selecting no padding. Padding is what's added to the end of the file. That in its own is the main reason that our encryption software and decryption software doesn't perfectly work with each other, with other softwares. This is due to different implementations at different degrees of padding in different directions on both the front and the end of the file. But in this case, we are able to decrypt using our software, and as you'll see, as we'll point out in a moment, we are able to see the padding that the other software added.
So this website returns the encrypted output in base 64. So we are going to have to create a file and then turn that base 64 back into binary, and then we will look at that with our program.
Now you will see that we are decrypting using our cipher blockchaining mode, which, as discussed earlier, is defined using the arguments of -C for the mode, -D for decrypt, -I for the input, -K for the key, and -V for the initialization vector. As you'll see, the output was not provided and an error was returned. We once again will add the -O argument, showing the beauty that we can provide any arguments in any order.
And there you can see the decrypted text. You can also see the extra padding at the end that the online program adds to fill out to a multiple of 128 bits.
In our implementation, we use all zeros, but as you can see here, they use 0B instead. Because our implementation only looks for our style of padding, it does not properly remove the padding added by a different software. Otherwise, the entire file is the same.